Hi everyone, this is Buggyhawk, and welcome to Turtle Time. In this episode, we'll take the Lumberjack program that we wrote last time and extend and improve it to work towards a self-sustaining forester. As you can see, I already have 4 trees planted in my forest. I'm working on the assumption that this is going to give us all the wood we'll need, but as we develop the program, it should become easy to see how we can expand that if necessary. First, we'll clean up the code so that it will be easier to extend. Copy the Lumberjack program to Forester. Edit the Forester program and change the name in the comment to Forester. The comments that we put in the code to describe what each section did are very useful, but they don't make any difference to the way the code works. We'll update that now and start the improvements. I've mentioned functions a few times. Now it's time to create some functions of our own. You can think of a function as being like a small program of its own. They're particularly useful for breaking up your larger program into more manageable chunks. As with so many things, it will become clearer as we actually do it. Initially, we had 9 steps that the turtle was doing, but these were quite specific. We were able to combine some parts together into functions. The first step was to use a loop to move to the tree. We can make that into a function and give it a meaningful name. Function goToTree. Now indent the code that we want in this function. That's just the comment and the loop. Just like loops and ifs, we tell the computer where the function completes by using the word end. End is like a period or full stop in the Lua language. I'd better explain a bit more about what we've got. Before I do, it's worth mentioning that there's quite a lot of flexibility in the syntax of Lua. Syntax is just the way the code is written. Things like spaces and blank lines, comments and brackets are often optional. But it's a very good idea to decide whether you'll use these things or not, and stick to that style to avoid confusion. The name of the function is goToTree. We use something called camel case to name functions. You can't have spaces in function names, so when I write them, they start with a lowercase letter, and then each word gets a capital letter, or hump, to help you read it. We've used the print function and some of the turtle functions within our programs. They're available to us because they are global functions. We don't really want our functions to be available to everyone, or get confused with other existing functions. So we'll do a quick update to say that this function is only for use within this program. You do that with the word local. There's another important change that we have introduced here. Previously, when we've executed a program, you've seen that the computer starts at the first line of code in the program and does that. Now we've introduced a function, so the computer will just make a note of its name for later use, and then carry on. This means the first code in our program is now the dig command. Let's wrap all the code up that we originally had into functions so that nothing's going to get executed out of sequence. After moving to the tree, the next logical step we took was to harvest the tree. Any tree would be harvested in the same way. Dig the bottom block, move into the space, harvest all the wood to the top, then move back down to where we started. We can group that code into a single function. Local function harvest tree. Indent the code. And add the word end. For those of you that were wondering, everything in a function between the brackets and the end is a block of code. The block of code inside the for loop is now called a nested block because it's inside another block. The last thing a forester needs to do when it's harvested a tree is to go home. Local function go home. Indent the code. You could split this into separate functions, perhaps one to travel back to the starting point and then another to unload the cargo and turn round. but at the moment this will be fine. Don't forget to add the word end. And there we are, at the end of the program. If you were to execute this now, nothing would happen. That's because all we've done in the program now is define a few functions. When the computer tries to execute the program, it will work its way through, noting where the goToTree, harvestTree, and goHome functions are, but it won't execute any of them. For ease of understanding, we'll always make sure that our functions are defined at the top of the program. That way, we and the computer know what's available and where to find it. So how do we make the program work? We simply call the functions. Let's add a comment so we can find things more easily. This will be the main program, and all it will do is call the functions goToTree, harvestTree, and goHome. Now when the program executes, it will work out where all the functions are, and then start by calling the goToTree function. It will execute that code block, and when it gets to the end, it will jump back to the next instruction here. Okay, before we execute this, we'd better make a backup copy on our disk. cp forester disk. Let's execute that new version of the program to make sure it works exactly as before. If you don't have a tree 3 blocks in front of the turtle, just pile a couple of logs there instead. Unless you spotted the problem and solved it for yourself, you should be seeing something similar to this. The turtle didn't move. He just turned around a few times. This is a common problem, and it's down to the fact that the turtle didn't have any fuel. In my case, it's because I dug up the turtle in the last episode, so that any remaining energy it had was wiped out. Do a manual refuel, and execute the Forester program to make sure it works. Then we'll update it to get the turtle to take care of its own fuel needs. Now we can get the turtle to start looking after its own fuel. From now on, we'll usually create a function to do something and then call that as necessary. At the top of the Forester program, add a function to check the fuel. This is going to assume that there is fuel in slot 1. That's not bad, but at the moment the turtle doesn't use all 80 units of energy for harvesting a tree, so refueling every time we start will be very wasteful. There's another function in the Turtle API that we can use to help here. The getFuelLevel function will tell us how many energy units the turtle has available. We can check to see if it has less than 80 units available, and if so, then we can get it to refuel itself. There's still a potential problem, because there might not be any fuel available in slot 1. We'll deal with that a bit later. For now, we don't need to worry about refueling it manually. We just need to make sure it has fuel available and it will take care of itself. The next step will be getting the turtle to harvest the tree repeatedly. We can do this by putting the main program code in a loop. We don't want to harvest the tree a specific number of times, so the for loop probably isn't the best choice. There is another type of loop we can use, the while loop. The while loop uses a condition to decide whether to execute its code block. A condition is just the same as those that we use with if-then. But what should we test? One option would be to use a condition that's always true. For example, while true do. There is a better option. Remember that there was a potential problem with the refueling function if there wasn't any fuel available. Let's use that. If we have another look at the Turtle API functions, we'll find that there's a way to see how many items are in an inventory slot. getItemCount. Using 1 as the parameter, we can tell it to check the item count in slot 1. When the computer gets to the while line, it will get the number of items in slot 1 of the turtle's inventory. If there is at least one item in the slot, it will execute the block of code. If the slot is empty, it will jump past the end instruction and finish. There's one more thing to deal with before we try this out. At the moment, as soon as the turtle has dropped its cargo and turned around, it will immediately go to harvest the tree again. We're going to need the turtle to wait a while to give a new tree time to grow. You can make the turtle wait by telling it, or more accurately, the computer running the program, to go to sleep for a while. This comes from a different API, the Operating System or OS API. os.sleep is used to tell the program to stop for a number of seconds. A realistic amount of time to wait is about 10 minutes, or 600 seconds. But for testing, to see how this works, we'll just give it a 10-second delay for now. Add the sleep instruction as the last thing inside the main loop. Save and exit the file. We should probably back this up to disk again. If you try to copy it as before, you'll find the computer complains that the file already exists. We could save it under a different name, or we could delete the original copy first. I generally use this second option. It saves clogging up a disk with lots of copies of very similar files and losing track of which one's the latest version. You can use delete or rm to remove a file. Just make sure you're not deleting the file you've edited on the computer. If we make sure there's no fuel in the turtle and try to execute this program, it should exit without doing anything. Put some fuel into slot 1 and try again. This time it should use up some fuel and start to harvest the tree. You can interrupt or terminate the program by right-clicking on the turtle and pressing and holding Ctrl and T. If you do that whilst the turtle isn't at the chest, you can either use the command line to tell the turtle how to get back, or, because we backed up the program, you can simply dig up the turtle and place it at the start again. A forester isn't going to be satisfied with just one tree. Let's work out how we can get it to harvest all 4 of these trees. Our program now works with 4 functions. First, it checks the fuel. Then, GoToTree moves the turtle forward 3 spaces, and after harvest tree is completed, it's 1 more space forward. That means that the turtle will be sitting on this block, facing forwards. This is why the trees I planted are spaced like this. Hopefully you've realized that if we call the same 2 functions again, GoToTree and harvest tree, the turtle will move along and get the second tree in line. Similarly, when that's done, we can go again. And then again. There are 4 trees to harvest, so we can put those 2 functions into a loop. For tree equals 1, 4 do. Indent those functions. End. One other thing that we'll need to change is the go home function. At the moment, that's expecting to be at the base of the first tree when it's called. Now it's 4 times further away. Find the line of code that sends the turtle home and update the 4 spaces to 16. Check your turtle is fueled and let's go for it. That's it for this episode. We'll have one more episode next time to put some finishing touches to the forester, including the planting of saplings after harvesting a tree, and also collecting the fallen saplings to increase its sustainability. Thanks for watching. See you next time.